A hit. A fine hit. Ah! Take the dead! Release the river!
Hold on!
Hold on, little hobbit!
Alright, I know Lord of the Rings is not exactly related to what we're doing, but it's still awesome to watch. Okay, so give me the benefit of the doubt. But there actually is one scene in that clip I showed you that is going to prove useful in the upcoming video. We're now going to talk about transistors. So take a closer look at this segment, because we're going to talk in detail about it.
Take the dead! Release the river!
Hold on!
Okay, that is a ton of water flowing, and it came from basically one end just tugging on some of the wood. I guess they didn't build that dam very well, but there you have it. One tug caused all this water to flow. This is the basic principle behind transistors. Alright, so let's backpedal. What is a transistor? Here, pictured on the left, is a bijunctional transistor, very standard. Here's a circuit diagram of a transistor, only it's one type. We'll talk about multiple types of transistors. And here is a transistor array, which you could find in a lot of electronics these days, notably processors. And I just want to show you guys real quick, transistors are really ultimately what enabled the technology boom, what enabled the digital age to come about. And I just want to give you an idea of how important transistors are and how far we've come with them. So transistors are mainly, they make up a lot of they make up they are at the heart of processors. Okay, that's how processors are enabled, is because of transistor logic. So it tells transistor count. So I'm just going to Google transistor count, and you can do this yourself too. And I want to show you two things. One is, here is listed for us the by date and by transistor count and by processor, it shows how many transistors are in any given processor. Okay, and so we start here in 1971 with, I'm assuming this is one of the, had to be one of the first, or maybe it's just one of the first that they documented, but transistor type processors. And you see there's 8,000 transistors. Now we come down here. Let's take a look. What's considered the Core i7 is considered decently. Oh, I guess that's not even new anymore. 2008. But some of the i7 processors are really considered nice these days. You've got on the order of over 1 billion transistors printed on. That's over 1 billion transistors printed on an area of 160 square millimeters. So that's 40 millimeters times 40 millimeters. And 40 millimeters that's 4 centimeters. So you can imagine 4 centimeters by 4 centimeters. There's over 1 billion transistors printed on a processor like that. And to give you an idea of how fast this technology has advanced, I want to talk to you about something called Moore's Law, which you may have heard about. And it's the idea that it says, curve shows transistor count doubling every 2 years. So Moore's Law is some guy made this hypothesis, I guess, that the transistor count on a processor was going to double every 2 years. And this graph is showing that on like kind of a log plot here, that is indeed been the trend. And this is up till 2011, so for a few years ago, and people are starting to say that it's slowing down now, that Moore's Law is coming to a halt, and that's for other quantum mechanical reasons that we might not get to in this camp, but there are definitely limitations at some point to how many transistors you can have in a given area. But that's for another day, maybe when you get to a higher level physics class. Anyway, so this just shows you how fast the technology has progressed in just 40 years' time. We've gone from a few thousand transistors to billions of transistors. That's a factor of 1 million increase in transistor count. So just to give you an idea of how rapidly this technology is expanding. So we still haven't really even talked about what the transistor is. Okay, fine, sorry. So we showed the video about the nths and about a small change affecting a large amount of energy, a small amount of energy input causing a large amount of energy output. So here again is a circuit diagram of the transistor. This is how you're going to see it. If you ever draw up a schematic of a circuit, there's the base, the collector, and the emitter. And so let's go over each of these in the idea of how the transistor works. We're not going to get too technical with the actual chemistry and physics that's going on behind the scenes of the transistor. We're going to kind of treat it as more of a black box and just say this is a general idea of how it works. Just kind of go with it. Okay, I know that's not great. I don't like doing that, but these are not trivial systems. These are very actually kind of hard to understand. And so we're going to keep it as basic as possible. So the idea is that you put a small current on the base, a small current, but it may be a larger voltage on the order of volts on the base, and a large current is going to flow from the collector to the emitter. And this is a well, we'll get to p-type and n-type in a minute here, but this is a general idea that you make a very small change at the base and a large change, a large current flows from the collector to the emitter. So really all you're doing is it's literally just a electronic switch. That's really all you want to think about. So when if I flick my finger on a switch, that's a very small amount of energy, but I could cause lights to turn on. I could cause a generator to turn on. I could cause some other change to happen. That's kind of how you want to think about this. It's a switch. Okay. So there are two main types of transistors in the physical sense. The difference between them is how they're quote unquote doped. And again, we're not going to get into the composition and the physics that's happening to make the transistors work, but there are two different ways to make a transistor. There's the N channel or PNP dope type, and then there's the P channel, which has NPN doping pattern, and they behave differently, and we'll talk about those different behaviors in a minute here. Also, I want to touch on the different. There are different types of transistors in the I guess construction sense. There are some that are constructed differently than others, so the more kind of common, more I guess not well known, but more basic type of transistor is the bijunctional transistor, the BJT, and then kind of the result of the bijunctional transistor, what came after that was the MOSFET, or metal oxide semiconductor field effect transistor, if that's a mouthful or not. And we will also try to talk a little bit about the difference between these two guys as well. So it's always, I think, the best way to learn at times is to just see an application. So we're going to actually jump right in to continuing on our pursuit of the digital nightlight. We're going to jump right into an application with something called a phototransistor. Okay, so it combines basically the ideas of an LED or a diode and a transistor. So as much as I'd love to teach you about this, I'm lazy, just like all other great programmers, except I'm not a great programmer really, but
get on with it. Yes, get on with it.